Hello there, inverse trig function time. So,
Where you're taking the inverse of a trig function.
right, so we need to remind ourselves perhaps what it means to have an inverse. So,
Let me give a visual cue.
Yeah.
If you've got your x coordinate and your y coordinate, when they trade places, that's an inverse.
That's an inverse. And so we talked about it back in the day in chapter 1, like if I have y equals x squared, how do I find the inverse? You switch the x and the y around, and then you solve for y. So that'd give you y equals plus or minus the square root of x.
Bingo.
And there is a graphical representation or significance where the first one has a graph of a parabola, and the second one, the graph is like a parabola lying on its side.
Right, tipped over.
And so all of our inverses are going to have symmetry across the line y equals x,
Right.
which you can see there, even though it's not a perfect drawing, you can see that.
There's a strong representation.
So what happens is whenever we come to this and we say, well, we want to find the inverse of y equals sine x, we're going to switch the x and the y.
But now we got to solve it for y, and that's where we run into an issue because what trick do we have to do this?
We can't just divide by sine because that's not how this works. This isn't sine times y, it's sine of y.
Don't divide by sine. That's no.
Yeah.
Just don't even think about it.
Yeah, it's kind of like when you have an absolute value that you're trying to get rid of. Well, we have to come up with kind of a special rule to get rid of the absolute value.
Right.
So the rule that basically they came up with back in the day is to just have...
Back in the day.
Back in the day with the mathematicians in Italy and other places.
Oh, the mathematicians in England.
Yes. You're really good at, or the pirate mathematicians.
Pirate math, ahoy!
Anyway, they came up with this thing that is called the inverse sine function, and we represent it with that -1. That's a button on your calculator. We've used it some.
Right. Now, here's the trick. That little -1 does not mean 1 over sine.
No.
That's not what this indicates.
No, it's talking about the inverse. Just like whenever we wrote inverses, we said it was the inverse of f equals and whatever it was. So if this was f of x when we started, here's the inverse, and we denote it with a -1.
Right.
The other way you can write it is...
It's not a reciprocal.
Arc sine.
And that's the way that you're going to see it most often in scholarly work.
Because it's a pain to put an exponent of -1 whenever you're typing. I actually used that trick the other day myself.
Just typed out arc sine?
Yeah, I typed out arc sine.
A lot easier.
Later on in the notes, actually, I think that happened. So the thing is, though, if we're actually talking about this function, if we look at what sine looks like, for sine to have an inverse that's a function, it has to pass the horizontal line test.
You could actually use the x-axis for this if you wanted to,
If you
Mrs.
wanted
Stevenson.
to, but I don't really like to. But yeah, you could.
Whatever.
You could, wherever. This does not pass the horizontal line test. It really fails it quite horribly.
Boss failure.
Yeah, it fails it like a boss.
Fails it like a boss.
And so what happens is that we have to, in order to come up with this inverse sine function, we have to restrict to...
Which is a function. That's the key word here.
Yeah, because we want it to be a function, we restrict what we're talking about for sine to we just look at between -π/2 and π/2. And we say, okay, just between -π/2 and π/2, is that right? Is that the restriction?
I believe that's the restriction.
Okay, between those, we do not repeat any values. This passes the horizontal line test. I didn't know those were still lines, but they are. Okay, if we extend it out any farther either direction, we will end up failing the horizontal line test. So that's why this graph, it doesn't really look like sine.
But remember, you have to trade part of sine, but also part of sine where you take x and y coordinates and trade them, which is why if you look at that original graph, you can't just spin it on its side and go, oh, there's the inverse.
Right, but we could do at π/2, we know it has to be 1.
Right.
So you flip it around. So here, and the axes here are bad, but at 1, we have to be at π/2.
Right.
I really should have changed the axes on this.
That's okay,
but
though.
You could graph it,
right,
and it should be up here. Okay, this point right here should correspond to this one, and then it's, yeah. Okay, so the important thing that you have to know for this is that sine has a domain of...
-π/2 to π/2.
Well, no, a range, sorry. A range, wait.
No, domain.
No, sine has the domain of -π/2 to π/2, which means that inverse sine has a range.
Oh, the range. Yes, the range of -π/2 to π/2 because x and y trade places.
Right. And so sine normally, this is sine's domain. Sine's range is normally from -1
to 1.
To 1, and so
The
our domain,
because the x and y trade places,
is from -1 to 1.
There we go.
Okay, so we're restricting this domain. Like normally it has a domain of all our numbers. We restrict it to this. It normally has a range of this, and then it flip-flops, and here's the domain and range of these.
Right.
So what that means is it's just going to make things a little bit weirder. Like before, whenever we had inverse sine, we said, you know, it could be in any of these 4 quadrants, but now we're saying it has to be either in the first or the 4th quadrant.
Right.
These are the only 2 places it can be.
Right.
So that's going to end up being important. Let's try some problems, shall we?
Let's.
All right, so let's do some problems taking the
Holy
inverse.
moly, that's a number in there, not an angle.
Right,
Ah!
right. Remember that what we're saying here is basically at what angle is sine, and then you fill in the blank with whatever number. So here we'd have 1/2. A is asking us, at what angle is sine 1/2? That's what the inverse sine
Pi
function
over 3.
means. Pi over 3.
Pi over 6. Pi over 4. 2 pi.
Instead of guessing, let's actually figure it out. It has to be in the 1st or 4th quadrant, okay? Because we define the inverse sine function to be 1st and 4th quadrant. So we have to say, okay, the opposite side is 1, the hypotenuse is 2. So yeah, what angle will this be? 30, which in radians is
How do you know it's
pi over
30?
6.
I don't understand.
Because it's a special right triangle. And this is kind of all we've been talking about for the last like
And quite
month
possibly
and a
it's
half.
on your circle.
And it's on the unit circle card as well. You could look and say, at what y value, like where's the y value that's 1/2? Oh,
Right.
look, it's at pi over 6.
And that's probably the easiest way to kind of go through some of these while you're learning how all this works, is to
Right.
double check yourself on your unit circle.
Definitely.
Just go, where is the, find all y coordinates of 1/2.
Why? Because it's sine.
Right.
That's why we're looking at the y value.
Okay. And then all the 1/2s that are positive, and then that narrows it down to 2, but then you can
We
only
want
be
the
1st or
one in
4th
the 1st
quadrant.
or 4th quadrant. And what actually is going to happen on this one, because we said 1st and 4th quadrant, right? So negative square root of 3 over 2 puts us down here. Okay, but this angle we've talked about before being, like we come around here and do the
Coterminal
positive,
style.
but we actually want the negative angle because
We've
want
got to
values.
be in the range.
Yeah, we want values between negative pi over 2 and pi over 2. And if you were to put, what would that be, 5 pi over 3? If you put 5 pi over 3, that's not in between those.
No, 5 pi over 3 is totally correct,
Right.
but totally not right
For this particular
problem.
Yeah, that's a 60-degree angle, and so, but that actually makes it easy. This is technically negative 60, which
Right.
makes it negative pi over 3.
Right. So if we just are like, where are all the places on your unit circle where the sine is negative square root of 3 over 2, 5 pi over 3 is totally legitimate. But the second we start talking about arc sine,
Yeah.
you can't use it anymore. You have to pick a number between negative pi over 2 and positive pi over 2.
Right, which is negative pi over 3.
These are all sines.
Yeah, because we've only talked about sine so far.
What?
Okay, let's just keep going.
Okay.
Okay, inverse sine of pi over 2. Hang on a second. That doesn't make any sense. In fact, that's undefined. That's like an error.
What? Why is it undefined? I don't understand.
Because we can't take the inverse sine of an angle. We use inverse sine to find an angle. We don't take it of an angle. If you were to type this in on your calculator, I know it says not to, but if you type it in, it'll give you an error. And the reason is that pi is approximately 3.14. So if we divide that out, it's approximately
0.07.
No, 1.57.
777.
Something 7, yeah, 1.57. You cannot have a sine of ratio that's bigger than 1. Like, this doesn't work. Because you're saying, if you have 1.57, you're saying that the opposite side is bigger than the hypotenuse.
Can't have that.
You can't have that. Your hypotenuse always has to be your biggest side. So this is an error, this is undefined, and this is to point out that, hey, you cannot take the inverse sine of an angle.
So
That's not what we're supposed to do.
anytime you get a number larger than 1, or smaller than -1, you're immediately going to be undefined. Can't
Right.
do it. Don't even worry about it. Just undefined and move on.
Now this on
Whoa,
D,
that's crazy talk.
this is a little trickier now because we can take sine of pi over 9. We can figure out what that is. We're supposed to do this without a calculator though. So we've got sine of pi over 9, which is right here. Okay, so we could set up this triangle if we, knew all of this stuff. And then inverse sine is what angle is this, right?
Yeah.
So we're taking inverse sine of sine, and those are opposites of each other. So what happens is that this is just pi over 9.
So the arc sine undoes the sine and gives me the innards.
Yes.
I like it.
But you have to be careful because on E, 5 pi over 6 is over here.
Oh, that's out of the thing.
And also, we can come up with this triangle real quick because that might be helpful. Okay, because this is a 30-degree reference angle because there's a 6 on the bottom.
Right.
So if I inverse sine this and I want to know what angle will give me sine of 5 pi over 6, which is 1/2. Like
right.
we can figure out that the inside of this is 1/2.
Right.
And so the inverse sine, though, what we want is this over here.
Because it's going to be the same thing.
Yeah, because we cannot have answers over here in quadrant 2 and 3.
But there is another location where the sine is 1/2.
Which is over here at 30 degrees, which is pi over 6.
I like it.
Okay, so that's inverse sine. Now let's talk about inverse cosine.
Okay, let's do it.
Tangent. Hey, so example 2, we're using a calculator in radian mode. That's nice of them to specify to evaluate these inverse sine values. So we want to do the inverse sine of -0.81. So on your Inspire, you press the trig button and you pick inverse sine. On the non-Inspire, you press second and then the sine button, and it shows you the inverse sine, and then you put this into your parentheses. You press enter, and as long as you're in radian mode, you should get
-0.944. I'm a good button puncher. There.
-0.944. Okay, and so what's going on is that is in fact the angle we want. Before, when we were doing things where we had to use the calculator for inverse sine, we had to be careful. But this is a -0.81. We're talking about a negative sign, so a triangle that's in the 4th quadrant.
It makes sense.
And yeah, this really is -0.944 because we're talking about a value between 0 and -pi over 2, which that is between 0 and -pi over 2.
That is totally, what you said is true.
Okay, so that's part of the reason why our calculator only gives us one answer whenever sometimes we have two, whenever we were doing this before, is because it is using the inverse sine function.
Right, it's trying to figure out, it's following the actual rules of that.
Right,
yeah.
So now can we just punch this all in at once?
Why do we need to, isn't it going to just be 3.49 pi?
Well, I don't know.
I mean, I don't know.
It shouldn't be because sine of I don't know.
So
no, because 3.49 pi is not in between -pi over 2 and pi over 2.
You're right, as always.
If this was something in between -pi over 2 and +pi over 2, it would just be that.
I get -1.539.
All right, so if we just think about this really quick, where is 3.49 pi? Well,
it's
here's
just
0,
snuck right
1,
around
2, 3, almost half.
Almost.
So here-ish.
3rd quadrant, where sine would be negative.
Yeah, sine would be negative, and so that means that we end up talking about this angle right here whenever we do inverse sine.
I like it.
Yeah.
Yeah.
Now, inverse cosine. So same kind of situation happens where the inverse cosine function, when we try to flip them around, it's going to work out to where we have basically an inverse, like we just have to say y equals the inverse cosine of x, and that is the inverse function. Same way that we did with sine. Or we can use arc cosine. Those are interchangeable. They mean the same thing. And we still have the situation of it failing the horizontal line test, so we have to pick values. But this time, we can't pick -pi over 2 to pi over 2 because even that fails the horizontal line test.
Yep.
So we have to end up picking from 0 to pi.
So because we pick from 0 to pi, we ensure that no x values are repeated, because that's where you get your failures, when you have a repeated x value.
Right. So for our cosine function, we are for between 0 and pi. And then our range is -1 to 1. And so we flip-flop them. That means our domain here is going to be from -1 to 1, and our range will be from 0 to pi. So here, what matters is all of our angles should be in the first and the second quadrant.
Right. Now, instead of looking at first and fourth, we're looking at first and second. Now, one thing that will help you with all of this is that when you're trying to figure out which quadrants to use, you should always be able to get a positive and negative value.
Right. Right.
So if you're trying to work with just sine and you get 2 positive values, you pick the wrong 2 quadrants.
Right.
So,
right.
And with cosine, if you don't get any negative values, you've picked the wrong quadrants.
Right. So cosine is positive here, it's negative here,
right.
So these are the 2 that we're going to pick.
Right.
They're the easiest.
Definitely.
Inverse tangent, let's knock that out real quick.
Let's knock it out.
Yeah, so the inverse tangent function is tangent to the -1. That's our symbolism, or we can use arctan. And whenever
same rules apply.
Whenever we look at this, we fail the horizontal line test, so we have to restrict it. And so what we do is we restrict it to between these 2 asymptotes closest to 0, which is -pi/2 to pi/2. It takes it and it flips it this direction.
And remember, it's not a 100% flip, because x and y coordinates actually trade places. So the shape is just a little bit different than if you were to knock the thing on its side.
Right. The domain here, we're restricting to, oh wait, it's not inclusive because there's asymptotes. -pi/2 to pi/2.
Right.
Okay.
So if you punch this into your calculator, that's where it's going to start looking.
Right, and then the range is -∞ to positive infinity. So what happens is we switch those for our inverse function, and we have -∞ to positive infinity.
For domain.
And then our range is -pi/2
to positive pi/2.
Positive pi/2.
Yep.
And so here we're concerned again with the first and fourth quadrant.
Right.
And so basically, put somewhere maybe in your notes that inverse sine is first and fourth.
Or you could just say -pi/2 pi/2.
Right.
Yeah.
Whichever.
Yeah, whichever way you're most comfy with. Yes.
So first and second, and then tangent goes back to first and fourth. So they're all in the first quadrant. The other one just depends on which one. So or put -pi/2 and pi/2.
Right.
And stuff like
Right.
that is also a good idea.
So let's dive into some problems now where we're trying to use the arcs, cosine, arc, tangent stuff.
Right. So part A, inverse cosine of -√2/2. We can look at the unit circle, because remember we're saying at what angle.
Will you get an x now? Remember cosine, x coordinate.
Right.
Here.
At what angle is x -√2/2, or x coordinate? And this is talking about the unit circle. Or if we draw a picture, we're saying, okay, where do I end up with -√2/2 for cosine, our x value? Oh,
adjacent.
That's
and
over here.
Hypotenuse.
Okay. And so what is this angle to get around to here? Because remember, we want values for cosine between 0 and pi. Since it's radical 2/2, this is a 45-degree angle.
You bet it is.
How do I know that? Well, one way to think of it is we can unrationalize this, and then we have -1/2. Or just recognize that if you see √2/2, it's all
45.
over your unit circle.
Yeah.
It's a 45-45-90 triangle. So that means that this is 3π/4.
You got it. You got it. 3π/4. We got to be in second quadrant for this bad boy.
Right, and that is between 0 and pi.
That is correct.
So inverse tangent, we're looking for,
inverse tangent.
And this is tougher just because tangent's not really as clear on our unit
It's not
circle.
always one you carry in your pocket.
Yeah, and so we're looking for where is our y value over our x value going to give us √3/1. Or if we draw a picture, this is positive, so that's first quadrant. Opposite side is √3. Adjacent side is 1. This is 2. Okay, so that's a 60-degree angle.
Right.
Which means this is pi/3. Okay, if you're trying really hard to use the unit circle on this, basically if we're having a y over an x, so our x value has to be 1, our y value has to be square root of 3. That's not on the unit circle, but if you put them both over 2,
the 2's will cancel
that's
out.
where you find your point.
Yep.
Okay.
So you could just look at the reduced fraction of an x and a y coordinate.
Like,
because it should reduce.
Yeah.
Like if you look at the different like pi
the
over 3,
numerators.
pi over 6,
Yeah.
when you look at those relationships between the x coordinate and the y coordinate,
yeah,
then it should reduce down to
2b
square root of 3.
Right. And this would, if you put this over
Right,
this. The
right.
2's cancel and it does work out. All right, another one without a calculator. We've got cosine of negative 1.1.
Undefined, can't have bigger than 1.
No, cosine of an angle. We
Oh.
can.
Oh, my bad.
So
Okay.
that's tricky. Tricky.
I was trying to
Cosine
remember what
of
you
an
said
angle.
earlier about that.
Yeah, no, this is telling us an angle. We're finding cosine of the angle negative 1.1, which means if we think about this, this is 0, this is negative pi over 2, which is about negative 1.57. And so we're in between there. We're talking about an angle here. Okay, this is negative 1.1. Now, if this angle had been between 0 and 3.14, these would cancel each other out, and that would be our answer.
Right.
But that's not what happened. So we have to figure out and relate that to this over here. Over here.
It's got to be positive. It's got to be positive, so it needs to go into the first
Yeah,
quadrant.
because cosine here is positive, because this side would be positive. Okay, so we've got to relate it to this triangle. Well, what is this angle going to be? It's going to be
1.1.
positive 1.1. So these can be pretty tricky. You have to really think through and say, okay, this triangle, we're going to have a positive or a negative cosine. We're going to have a positive, so that puts it in this quadrant. So if we had an angle over here where we'd have a negative cosine, we'd have to flip it up and it'd be up here.
Right. But if you'll notice, though, once we figured out where the angle was, the arc cosine canceled out the cosine.
Yeah, it is canceling out, but we
Right.
did have to take
But we
into
gotta
account
do
it wasn't the
the-
exact same.
Right. Okay, these
These are
you
kinda
gotta
tricky.
pay attention
You gotta
to.
pay attention because it matters.
Yeah, like with most math topics, paying attention is critical to
Yes.
your success.
Yes.
But now, notice here we've got cosine of an arc sine, and before we were like, hey, look, those things cancel out. You get the number in the middle. You can't do that now. They're not the
They're
same
not the
thing.
same. Yeah, so these are not inverses of each other, so we have to actually think this out. Inverse sine of 1/2, we're asking at what angle do we get a sine of 1/2? So we can draw ourselves a nice little triangle here. Oh, this is 60 degrees.
That's pi over 3.
Which is pi over 3. So,
But we're not done.
But we're not done. Now we need to find cosine of that.
But
cosine
wait, there's
of
more.
pi over 3. No, that's it. Cosine
Oh.
of pi over 3 is, well, we already have this triangle drawn, so it's square root of 3 over 2.
Right. I was trying to do
So-
one of those just made for TV commercials. But
Oh.
wait, if you act now.
Yeah, well, but there wasn't.
But there's more.
But
If
there
you act
wasn't.
now. Okay.
Okay. So.
Can you, that one, 7 pi over 4.
7 pi.
Totally.
What?
Totally 7 pi over 4. Cosine undoes cosine.
Cosine of 7 pi over
Oh yeah,
4.
work it out. You'll
Oh,
see I'm right.
But cosine has to be between 0 and pi.
Oh!
This is not
Dadgummit.
between 0 and pi.
Shucks and darn it.
That's so sad. I'm so sorry for you. Okay, so cosine of 7 pi over 4 is over here. We've got negative 1, 1, square root of 2. This would be 45, 45, 90 triangle. That's how I got those sides. Cosine is 1 over the square root of 2. Well, we want to figure out at what angle do we have positive 1 over square root of 2 that's between 0 and pi.
First quadrant.
So that's the first quadrant. So we move up here and we say, okay, it's this angle, which is pi over 4.
Now, watch what Mrs. Stevenson's doing here. When we were given a cosine a second ago, the cosine was the outer function. We had to provide a specific x value point. Now this time the arc cosine is the outer function. We have to provide the angle.
Right.
So you've got to pay attention to what number is on the outside.
Right. So we had to say, okay, well, cosine of this is positive 1 over square root of 2. Well, at what angle between 0 and pi do we get 1 over square root of 2? That was the process there. Okay, arc sine of cosine of pi over 3.
Better find where pi over 3 is.
Pi over 3 is at 60 degrees right here. Square root of 3, 2, 1. So cosine is 1/2. So inside of here, this is 1/2. We want to find arc sine of 1/2. Well, that's just square root of 3 over 2.
Right.
Right, okay. Cool. That one.
I feel like there's got to be more than that to that.
Nah, I don't think so. That's it. I'm pretty sure.
All right.
Yeah. Hey, example 5, last example.
I feel like we've done more than 5
Find
examples.
an algebraic expression equivalent to the given expression cotangent of arc cosine x.
Be strong with Pythagorean theorem here. Be comfortable in your knowledge. It's going to come in handy.
Okay, arc cosine of x is saying at what angle do we get x over 1 as our adjacent
Side.
over our hypotenuse.
Right.
So let's just, does it matter if it's positive or negative? I guess let's just draw a triangle.
Just draw the triangle.
Okay, a right triangle. Here is our angle. The adjacent side is x.
Yes.
And the hypotenuse, because we have to make this a fraction,
Yeah,
the hypotenuse is 1.
Right.
Well, so if we want to find cotangent, we need the opposite side. So what is the opposite side if we have a hypotenuse of 1 and a
Rewind to the
adjacent
beginning
is
of this
x?
video, Pythagorean theorem.
Why was that at the beginning of the video?
Well, I just said that. Just the beginning of this slide.
Beginning of this slide. Yeah.
Sorry.
So what we do is we square root 1 squared minus x squared, which if you simplify, all we can do is say, oh, well, that's 1 minus x squared.
Now,
Do
so help me. I will kill an animal.
Like the reindeer behind us?
Yes. If you write down that this is equal to 1 minus x, something is going to die. I don't know what it's going to be, but wow, don't do that. Yes. It's bad math. Just no. Okay. Done.
See, that's burning in flames.
So, yes.
It's not true.
That
you
is
cannot.
totally
Don't
false.
simplify it. Okay, so this side is 1 minus x squared underneath our square root. Cotangent is opposite over adjacent. Once we have our triangle, we're finding cotangent of this angle. So opposite over adjacent is square root of 1 minus x squared over x.
I'm happy with that. I'm happy.
You should be, because that's like, there's nothing else to
Don't.
do.
Yeah, don't.
This is not a you could do this situation. That's it. That's the answer. There is nothing else. That's it. You can't change it. If you
mark
change
an
it,
X out anywhere, the math gods will come for you in your sleep.
or on the next test.
No, in your sleep.
In your okay.
Yeah.
Is that why I dream about math?
Yeah.
Because I keep doing it wrong?
No. You're having good dreams.
Okay. Hey, happy 4.7.